So now for this example, we're going to be graphing equations. So it says graph the equation in two variables, y is equal to negative 3x minus 2 using an xy table. And a couple of things here. Here I have this coordinate system. And if you have maybe some graphing paper or some sort of grid paper that you can use to help you make these graphs, it certainly makes things a lot clearer and easier to do. So I already have this coordinate system set up here. And an xy table is exactly that. It's a table with these values of x and y in here. So first, let's go ahead and I'm going to rewrite this equation here. Y is equal to negative 3x minus 2. And then we make this table. So I'm just going to go ahead and go like this. And here are going to be our values for x. So all we do is come up with some values for our x variable here. And you could keep them simple. So we'll do 0, 1, 2. We'll put in some negatives here, negative 1, negative 2, negative 3. So you should do about, I don't know, 4, 5, or 6 values for x. And then y, for an equation like this, x is known as the input variable and y is known as the output variable. X is also called the independent variable and y is also called the dependent variable. So y depends upon what x is, or if I input x, what is the outcome for y? So we'll do that. So since x here is 0, then we have y is equal to negative 3x, that's 0. Negative 3 times 0 minus 2. Therefore, y has got to be negative 2 when x is 0. And then we just kind of go down the list here. So here's 1. So y is equal to negative 3 times 1. Negative 3 times 1 is negative 3 minus 2. So then y has got to be negative 5. For 2, y is equal to negative 3 times 2. That's negative 6 minus 2. That's negative 8. Negative 1, y is equal to negative 3 times negative 1. Negative 3 times negative 1 is 3. And 3 minus 2 is 1. Negative 2, y is equal to negative 3 times negative 2. Negative 3 times negative 2 is 6. And 6 minus 2 is 4. And negative 3, y is equal to negative 3 times negative 3. That's 9. And then 9 minus 2, that's 7. And you can have more, or they don't have to be like this, but you should do just enough, simple enough, to where you can see the graph of the line start to form on your coordinate system here. So what this has done, what this has formed, is it's formed these coordinates. So when I put in a coordinate of 0, the output coordinate is negative 2. So then I go ahead and I plot that point, and we'll do that. So this is our origin here. I'm just going to go and count down here 0 and then count down 1, 2. So maybe here is 0 and negative 2 right here. Here is 1 and then negative 5. So if I go over 1 and then count down 5, 1, 2, 3, 4, 5, and here's my point right there. 2 and negative 8, we go over to 2, 1, 2, and negative 8, 1, 2, 3, 4, 5, 6, 7, 8. And there we go. And hopefully you could see the line start to form here. Negative 1 and 1, we come back 1 right here and up 1. Negative 2 and 4, we come back 2, 1, 2, and up 4, 1, 2, 3, 4. And then we have negative 3 and 7, come back 3, 1, 2, 3, and then up 7, 1, 2, 3, 4, 5, 6, and then 7. So you could see where the line would go through right here. So then very carefully, we'll go ahead and we'll draw that line. And we'll go ahead and put arrows on the end of the line. That shows you that that line goes off in either direction forever. But there is the graph of the equation of the line y is equal to negative 3x minus 2. And there you go.